Assalamualaikum warahmatullahi wabarakatuh. Welcome to Wisdom International School's digital classroom for mathematics. So children, in the previous session, we had looked at polynomials. We started with the lesson polynomials. We looked at the zeros of the polynomial and how to find the degree of a polynomial, right? And based on the degree, we also named the polynomial, right? So now we will look at a long division method. That is when division is done between a polynomial and a polynomial, okay? So now in this case, you can see that they have given you divide x cube plus 3x square plus 3x plus 1. So this is a polynomial divided by, you're supposed to divide this by x plus 2, right? So we will look at how to do this. So this is like our usual division, like how we do it with numbers. Similar way we write it like this, okay? So we write the x cube plus 3x square plus 3x plus 1 inside and then the x plus 2 outside as it is, okay? Now, how do I divide this now? You have an x cube over here and I look at this x over here, okay? I want to see, I have to find out what I can multiply with this x so that I get x cube, okay? So this x is supposed to be multiplied with x square, only then I'll get x cube, isn't it? So I write that x square over here. So x multiplied by x square gives you x cube, okay? So I write x and I write x square over here. I write x cube over here because x times x square gives you x cube. Now, I also have a 2 over here, so I can't just neglect this 2. So I'll multiply this 2 with the same x square which we have written over here, okay? So 2 multiplied by x square gives you 2x square. So that 2x square, I will write it below the 3x square because they both turn out to be the like terms, okay? So we have got x cube plus 2x square. So we have multiplied all the numbers over here with the x square which we have written, right? Now what do? We will flip the sign. So we will change the sign because we need to subtract it. So see, the sign in front of x cube is, nothing is written over here. So it's assumed that it is plus. So we change it to minus. Now here it is plus, so we change that also to minus, okay? So the plus will be changed into minus and the minus will be changed into plus, okay? Now when I do this, the x cube and the x cube can be cancelled. X cube minus x cube is 0, so I can cancel it. And then 3 minus 2 is 1. So 1 I need not write it. So it's 1x square. I need not write the 1. I simply write x square, okay? Now I pull down the 3x and I pull down the 1 with its signs, respective signs, okay? The 3x will come with the sign over here, that is plus 3x. And the 1 will come with the sign over here. Now after that, now I have a x square over here. So I will see what I can multiply it with this x so that I get x square. So I need only one more x, right? X into x is going to give you x square. So I will write plus x over here. So x into x gives you x square. So I write the x square now. Okay. Now what do? This 2 also has to be multiplied with the x over here. So x into 2 gives you 2x, right? So now I will again change the sign as usual. So this becomes minus, this becomes minus, okay? Now again x square minus x square, this gets cancelled. Now let's go down, okay? A minute. Okay, so now 3x minus 2x is again 1x, which will be written as simply x, okay? Now, I'll have to pull this 1 down, okay? Now, I have an x over here. I will see what has to be multiplied with the x so that I get x. So, I already have an x over here. So, I simply need to multiply it with 1, isn't it? X into 1 is going to give you x. So, I write 1 over there on top. See, I have written over here. X into 1 is x. And again again that 1 has to be multiplied with the 2. So 1 into 2 gives you 2 over here, right? Now I will change the sign as usual. So when I change it, the x and x gets cancelled and I get 1 minus 2 is minus 1 because the larger number is 2 and it has got a negative sign. So I'll put a minus 2, okay? So the red sign which I have taken over here, those are the signs which we need to consider. Alright, so now here the minus 1 turns out to be the remainder because you see over here you have a x and you can't multiply any number, any x with any number so that I can get a 1, right? So what do? I just keep it as negative 1 itself. So that's my remainder and the dividend is the one which you are dividing it with. So this is the dividend, okay? X cube plus 3x square plus 3x plus 1. This is what you are dividing, no? So that is your dividend and by what are you dividing this dividend? That is x plus 2. That turns out to be your divisor, and the quotient is the answer which you got at the top. See over here, x square plus x plus 1 is the quotient. Okay, so this is what is long division method. So you can get any kind of a remainder over here. You can get a number, positive number, negative number, or 0. Okay, sometimes you can get an answer with the x also in the remainder. All right. Okay, so now you have a rule. Okay, this is the rule. Dividend is equals to divisor into quotient plus remainder. We would have learned this in junior classes using simple numbers. Now the same thing, same formula is applicable to the polynomials also. Okay, now I hope you people have understood what is long division method. So I want you people to practice more of this kind of problem so that you get you get expert in this. Okay, you understand this better. Now come to this remainder theorem. So remainder theorem, so first we will learn the statement. It's better to memorize this statement. Okay, if a polynomial p of x is divided by a binomial x minus a, the remainder obtained is p of a. See, if you have a polynomial, some polynomial is there, like in the previous case we had got x cube plus 3x square and so on, right? So that could, let's say that has been divided by some binomial x minus a. So in this case, x minus a was x plus 2 in the previous question, right? So we will I'll explain it with the same question. Okay, and what remainder do you get? See, if I ask you divide something and get the remainder, what do you usually do? You actually divide it and find the remainder, isn't it? Now what we are going to do is we have a remainder theorem with using which we can just get this answer in 2 steps instead of sitting and dividing the whole thing. Okay, so now see, if I give you the question as find the remainder when x cube plus 3x square plus 3x plus 1 is divided by x plus 2. Okay, if the same question, the previous question, the same example, I'm going to do it. Okay, but here I'm not going to divide it. There is no long division method involved. I'm just directly and trying to find the remainder. So what do? I have a x minus a, right? According to the statement, if something is divided by x minus a, so in this case they have given x minus a as x plus 2. So what is there in place of a? In place of a you have minus 2, isn't it? Only then you will have x minus of minus 2 as x plus 2, right? So a is actually taken as minus 2, or you can even take it as x plus 2 is equals to 0 and you get x is equals to minus 2. So what you are going to do now is your polynomial given equation is x cube plus 3x square plus 3x plus 1. In this, wherever you have x, you are going to put minus 2. Okay, so put minus 2, p of minus 2. When it was p of x, you had everything with the x. Now if I have p of minus 2, I will put every x in the, wherever you have x, I'll put it as minus 2. Okay, so here also I have put it as minus 2. X is replaced by minus 2. Here also I'll replace by minus 2 the whole cube. So here it will be minus 2 the whole square. Here it will be minus 2 and everything else is written as it is. Okay, now we will solve this. Minus 2 the whole cube, minus sign will be retained over here. 2 cube is 8 plus 3 comes as it is. Minus 2 the whole square turns out to be plus 4. Okay, and then you have plus minus is minus. 3 2s are 6 plus 1. Okay, then you have minus 8 as it is plus 3 4s are 12 minus 6 plus 1. So this becomes minus 8 plus 12 minus 6 plus 1. So I add both the negative numbers together. Minus 8 and minus 6 could be written as minus 14. And I add both the positive number together. 12 plus 1 is 13. Minus 14 and plus 13. One with a minus sign, one with a positive sign. So I have to subtract it. 14 minus 13 is 1. And I'll have to put the sign of the larger number. The larger number is 14. So I put minus 1. So this is my remainder. So this is what I got even using the long division method also. Right? So instead of using the long division method, this is another way of finding the remainder. Okay, so if in test, if they specifically tell you to do find the remainder using the remainder theorem, you have to follow this. Okay, all right, now come to factor theorem. Okay, let's just look at this. Yeah, so factor theorem is, according to factor theorem, if f of x is a polynomial of degree n, According to the factor theorem, if f of x is a polynomial of degree n equals to 1 and a is any real number, then x minus a is a factor of f of x if f of a is 0. So if you, instead of we can understand this better by the remainder theorem concept itself. See, the remainder theorem, what did we do in remainder theorem? We just took the number with which you're dividing it, right? You take it as x minus a. If it is, we are going to take that as a and we plug it into the polynomial for x, right? So the same thing we do it over here also, and we try to find the remainder. Okay, and if the remainder is 0, then we call that this particular term is a factor. Okay, if it's not 0, then it is not a factor. Okay, like in the previous question, if we look at the previous question, we got the remainder as -1, right? So then that particular term, that is x plus 2, is not a factor of x cube plus 3x square plus 3x plus 1. Alright, so now in this I will show you one example. If they ask you, check if x minus 1 is a factor of 2x cube minus 5. Okay, so what do we do over here? We try to see if it is a factor or not. So we take x is equals to 1. How did we get x equals to 1? By x minus 1 equals to 0. So x is equals to 1, right? We move the 1 to the other side. Now we take this 1 and we try to substitute into the x in the equation, in the polynomial. So 2x square plus 3x minus 1. So here we substitute 1 for the x. So 2 1 square plus 3 of 1 minus 5. So 2 1 square is 2 itself. So 1 square is 1. So 2 into 1 is 2 plus 3 into 1 is 3 minus 5. So you get 2 plus 3, 5 minus 5, which is 0. So since this gives you a remainder of 0, we call that, since p of 1 is 0, x minus 1 is a factor of this. Now what do you mean by factor? See, for example, if I have a 12, okay, if I have a 12 over here and I divide this by 2, so I will write 2 6 are 12 and I get a 0 in the denominator, right? So this means that 2 is a factor of 12. Okay, so here I can write 2 is a factor. So by remainder only we decide if it is a factor or not, okay, of 12. Now if I divide this 12 by 5, for example, 5 2s are 10 and I get a remainder of 2 over here. So 5 is not a factor of 12. Understood? Similarly, when you have a polynomial, what do? We try, either we divide it and see what's the remainder, and if it is 0, we say that yeah, it's a factor, and if it's not 0, if it's not a factor. But then you have a easy factor theorem where you just substitute for the x as a and you find the remainder. Okay, and if the remainder is 0, you say that it's a factor, and if it's not 0, you say that it's not a factor. That's it. Okay, so let's look at one more example. Okay, so based on this theorem, they may give you a different kind of a question, not a direct question, little twisted question. So like in this case, they say find the value of k if x plus 1 is a factor of this. So here they are already telling you, they're not asking you to check if it is a factor or not. They're already telling you that it's a factor, and we need to find that if it is a factor, what should be this k. Okay, so what do? Here we have x plus 1 is a factor, they are saying, right? So then you take x is equals to minus 1, right? How do you do that? X plus 1 is equals to 0, so x is equals to minus 1. So this is how you get this x is equals to minus 1. Okay, so now we substitute this minus 1 into this 3x square minus 4x plus k. So let's substitute 3 minus 1 the whole square minus 4, again for the x you put minus 1 plus k, and since it says that it's a factor, it is supposed to be equal to 0, right? If it is 0, we say that it's a factor, and if they tell you that it's a factor, then it should be equal to 0, right? So we equate it to 0. Now you see minus 1 the whole square is 1, so you get 3 1s are 3, and then you have minus 4 into minus 1, minus minus becomes plus, plus 4, and plus k should be equals to 0. So you get 3 plus 4 is 7 plus k equals to 0, or k equals to minus 7. Got it? Okay, so this is how you find the value of k. Okay, so these two theorems, you memorize the statement and you also go over the examples which I have told you. This examples, whatever I have told you, you need not write in the classwork. Use just for you to understand. Okay, I want you people to finish the exercise 2.3 and 2.4 in your classwork. It's all based on what we have done today. So if you can just keep these three example problems as a reference. Okay, referring to this, you can try to solve those these exercises. Okay, so inshallah we'll meet in the next session. Allah Hafiz. Thank you.